So this is 13.15. Indicate the type of solute-solvent interaction that should be the most important in each of the following solutions. So the first thing that you want to do with these is take and sketch the Lewis dot structure for each one so you know what kind of intermolecular forces are involved with each one of the particles themselves. And so carbon tetrachloride, CCl4, would be 1 carbon, 4 chlorines around it. It would be nonpolar because it is perfectly symmetrical. There would be pull for electrons in each direction. And then the other item that it says it dissolves in would be benzene C6H6, which we usually represent as a hexagon like this, and then it has a resonating double bond that goes all around like this. And this, of course, is also nonpolar. And so if both items are nonpolar, when they mix, the substance to start with only have London dispersion forces and only have London dispersion forces, and so when they mix, the only attractive forces they'll have are London dispersion forces between one another. There are no dipole forces, there are no hydrogen bonding forces, there are no ion dipole forces. And maybe that was a better place for me to start, was there are 4 forces that you're looking for. The first force that you're looking for is London dispersion forces. And of course, if that's all that exists, that's the thing that holds something together. The second kind is a dipole-dipole force. It happens in 2 dipole molecules. The third kind is if it has hydrogen bonding. And remember, you have to have an H connected to an FO or N in the molecule for that to happen. And then the fourth kind would be an ion dipole force, and that would happen when you have a positive or negatively charged thing, and then that would be attracted to something that has a dipole. In letter B, it says methanol in water. So water, of course, you know the Lewis dot structure for that. That has an H connected to an FO or N, so that's going to have hydrogen bonding forces amongst itself. And then methanol, CH3, and then OH coming off of there looks like this. And so this also would have hydrogen bonding forces because it has an H connected to an F or N. And so the interaction between these two, when they dissolve, the strongest interaction would be hydrogen bonds. Letter C, KBr in water. So KBr, when it goes into water, dissociates into KH+ and Br-. And water molecules, which are polar, have a negative end to them and a positive end to them. And this negative and positive interaction right here would be a ion dipole force. Or it could be this way, where we have the negative end right here attracted to the positive end right here, and that would be an ion dipole force as well. So ion dipole would be an answer for letter C. And then lastly, letter D, we have HCl and acetonitrile. So HCl, of course, is a polar molecule where there's a negative charge here on the chlorine, positive charge here on the H. And then acetonitrile, it's going to have the CH3 down here, and that's going to connect to another C that's triple bonded to the N right here. And that would make a dipole going this direction, and it would be negative here on this side of the nitrogen. That would attract to the positive side of here on the hydrogen, and so we would have a dipole-dipole force between those two. So when you encounter a problem like this, those are the 4 types of forces that you're looking for, possibly. Sketch the Lewis dot structure, see what's involved in just that substance, and then look to see how it matches with the other substance that it's dissolving with.